Oh wow. Yes. Oh, so I can say there's treats in the. Okay. Maybe we want to let people go before I start. Yeah. So yeah. Does everybody want to go get treats in the? There's coffee and donuts in the kitchen. Vicky's told me. If you want to go now, go for it. We'll start in a few minutes. Yeah. Testing. 1, 2, testing. 1, 2, 3. Testing, testing. Testing. 1, 2, 3, testing. Testing. 1, 2, 3. There we go. All right. Do we think everyone's back? Probably now, right? No empty computers? Okay, cool. I'm not too familiar with who's in the class, so you're going to have to help me with that one. Okay. Well, all right. Let's get started. Good Monday morning. A little tough for me to get up in the morning and come do this. I'm not very good in the mornings. Wish lectures at 9 p.m. It would be a bit easier for me, I think. This is the first time I've stood in front of you to speak about some of these things, and my name is Karl Jensen. I've been teaching here for a couple of years now. I'm going to tell you about HTTP today, and this is a really important topic. HTTP is a very important topic. It allows us to communicate on the web. So, you know, we've got the internet, we've got all these computers. One of the ways that we can transfer information between these computers is through HTTP. If we learn the language of HTTP, then we can participate in this communication. That's how we build web servers. So I'm going to teach you about that today. There's also this term API, which is Application Programming Interface. And this really just means sort of anything that's intended or designed for you to use, to build on top of, to build your applications on top of. And so today it's how do we use application programming interfaces that are designed in HTTP. that sound okay? Cool. So the whole purpose of, the purpose of learning this is to be able to communicate on the web, and the way we're going to do this is by building a project. This is your first project. It's the small project for the whole program. It's going to be today that we work on this. And what you're going to be able to do is make a request to GitHub through their API, and it's going to give you back a list of contributors to a repository. And included in that list of contributors, you're going to have a link to their avatar, the avatar of the user who contributed to this repo. And so you'll download every single image that represents someone who contributed to a repo. And that's what the project is all about. And I'm going to show you some of the ways that we can do that today, including in the afternoon lecture when we talk about how do we build applications in Node and do these types of things in Node. All right, so here's that objective. We want to use Node.js as the runtime environment that we're working in right now to make HTTP requests. That's the protocol we're going to use to do the communication over the web, to github.com, which is the address of a machine that's sitting somewhere on the network. Questions about this? All right. So protocol, let's define this first before we move on. And I've tried to come up with or put together a, I guess, kind of short, quick, kind of concise definition of what a protocol is. So let's go over this quickly, right? We got these rules. And the reason why we have rules is because we need to make sure that both sides can understand each other's communication. So by following these rules, then we write messages in a certain format. Then the thing on the other side who understands HTTP can read those messages. So we have to follow these rules so that the communication is understood by both parties. Exchange of data. So this is actually transferring data between machines. And then that's the devices. So it could be a phone or a laptop or a web server, lots of Internet of Things out there as well. So by following these rules, we can exchange data with between devices. And this is the protocol we're going to use for this is HTTP. Has anyone heard of the KKJP? It's another protocol. No? Okay. So this is the knock-knock joke protocol. Yeah, sorry. I got this idea from someone who lectured here before, and I thought it was a pretty good analogy for this idea. Because with the knock-knock joke, we have to understand the rules of the knock-knock joke, otherwise, well, it's not funny no matter what, but if we understand the rules, at least we can get to the end of it, right? So how a knock-knock joke works is someone starts off by saying knock-knock, and this kind of initializes the communication, right? The other side now knows, oh, knock-knock. I understand when someone says knock-knock, I should say who's there to complete that sort of two-way communication. So I say who's there, and then the other person, now they get to say something, whatever they're going to, now this is where the joke comes from, right? So they say something, in this case they say orange, and then the response on the other side, they're meant to take what was told to them and then add the word who to the end of it, right? So they say orange who. So these are the rules that govern the exchange of a knock-knock joke. And by the end, the final thing, the person can say the punchline, which is orange, you going to let me in? Or let us in, it's cold out here, or whatever the thing is that's supposed to be funny. But the idea, the point is that to tell a knock-knock joke, we have to follow the rules. That's the protocol. And if both sides understand the protocol, we can get to the end of the communication, right? All right. Lots of different protocols out there that you've used. Does anybody have a favorite protocol? It's okay if you don't. I don't either. So HTTP is the one we're learning today, but you may have heard of some of these other ones. You may have used some of these. I'm positive you've used them, even if you didn't know that you were using them at the time. FTP is a little bit older now. Nowadays, we tend to use GET instead of FTP when we're doing the things that we used to use FTP for, but it's still a good way for us to transfer files. Yes? Oh, wow. I messed that up. I didn't know that there was a... Oh, yes. Okay. Really sorry about that, Calgary. It's been 2 cohorts in a row. We haven't had any remote, so I totally missed that one. Let's do a quick review just to make sure everyone knows where we are right now. You didn't miss a whole bunch. We got coffee and donuts, so we started a few minutes late. Let's start over. So I'll introduce myself first. I'm Karl. Karl Jensen. So if you want to find me on Slack, it's just Jensen. And I've been teaching here for a few years. I did want to mention one thing, and so it's good that we kind of had to start over. I like to get feedback, so if you want to give me feedback on Slack, or you can give Davey the feedback for me, and he'll give it to me anonymously. Either way works for me, as long as it gets to me. That's the important thing. I like to know about pace, too fast, too slow. Does this material help? Am I going on too many tangents? That kind of thing. I like to know that so I can potentially take it into consideration. Is that all right? All right, cool. So let's go over the review. I wanted to bring up 2 acronyms here. HTTP, so that stands for the Hypertext Transfer Protocol. This is the protocol we're going to use for communication on the web. We're going to make requests from our browser to a web server, and the server is going to send responses back, and that's how we get data into the browser. So HTTP is the protocol we will use to do that communication. And then application programming interface is it's just meant to be something that is designed for you to use to build software on top of. And so an HTTP API is a programming interface that is accessible over the HTTP protocol. And we're going to be using some of those today, and you'll be using those in your activities today as well. So this is the project that we're going to be building today. It's the GitHub avatar downloader. We'll make a HTTP request to GitHub. We'll receive a list of collaborators, including all the images for those collaborators, and then one by one we'll download the images for those collaborators. So we'll have to use a lot of the techniques that we're talking about today. So I'll talk about a protocol quickly. This is a definition we're going to need to know. So the set of rules governing the exchange of data between devices. We need these rules because we need to make sure that both sides understand how to communicate. We've got the knock-knock joke protocol. I'm sorry for having to go through this again. This is just an analogy of how this kind of might play out in the real world. For a knock-knock joke, you need to understand both sides of communication. We need to make sure that when we start the joke off, we respond in the right way, that the next piece of communication follows the right format. Otherwise, the joke kind of falls apart. And in order to get to that punchline, we need to go through all of those steps. So the protocol is the rules that determine the communication between these 2 parties. Okay, so this is kind of where I left off when I got the bad news that the stream wasn't sent out properly. So that I didn't do that right. So let's talk about common protocols. Some of these may be familiar to you, and I guarantee that you have all used these protocols, most of these protocols, even kind of behind the scenes without your knowledge. So FTP stands for the File Transfer Protocol. It used to be that if I want to get my website onto a server somewhere, I would connect using FTP, and I would just sort of like drag and drop my files onto this server, and it would upload them one by one. And if I wanted to, I could overwrite the files using FTP still. And so nowadays I use GET instead, but GET uses protocol as well. So there's all these protocols that we have to use to manage the communication. So some more protocols. POP3. This is the Post Office Protocol version 3. And this would be used for older email systems. Ones where you would actually download the email from the server onto your local machine, and then it would maybe no longer be on that remote server anymore. And so I'm sure there's not many people familiar with that here, but nowadays, yeah, and me. And nowadays we use IMAP, and this is what people are actually more familiar with, but it's this protocol that actually syncs your email to the server. So you're downloading a representation of that email, but this email stays on the server, and if you connect with a different client, then you'll just download another copy of that. So this is obviously way better, right? These things improve, and people decide to use different ones over time. SMTP is the Simple Mail Transfer Protocol, so this is how we actually send mail out. This one hasn't really changed or hasn't really been replaced, but yeah, whenever you're sending an email, you're using SMTP to do that. Okay. So HTTP is what we're into today. and the rules and learning the rules of HTTP. That's what we have to get through. So imagine you got your phone, you got your servers, and you want to retrieve a page of, I don't know, the latest sports scores or something like that. You need to make a GET request to the server, and the server will then compile something for you, some code maybe. It'll go into the database and get all the scores from the day before, and then it'll put it into tables in HTML, and it'll send that HTML back to you just as plain text, and that plain text will get read by your browser, and the browser will then render it using CSS and all of the nice stuff that comes along with the HTML. So this is the main model we're going to use for communication on the web. And HTTP always follows this request response model. I've defined up there what we call the request line. The first line of a HTTP request is called the request line, and it includes two very important pieces of information and one maybe kind of important piece of information. But that first piece of information there, it's called GET. It says GET. GET is the method we're using on that request. So when I want to retrieve data from the server, I'm going to do a GET request, and that's going to it's just the way that I tell the server what type of an operation I'm trying to do. And then I also have to tell the server the second most important piece of information is, if I'm doing a GET, what is it that I'm getting? And it's that / here that is the path that we're trying to get. And so when we say get / what we're saying is just get the document that represents the root of this website. But we can put other paths in there to get pages about the site, contact, blog posts, whatever you want. The third thing, and what I say is not that important, is this version. If it says HTTP 1.1, we're okay with that right now. Things, we're going to have 2.0 soon. I'm sure we'll have 3.0 after that shortly. So, but these things take time to gain traction. So for today, what you'd expect to see most of the time is HTTP 1.1, and that both sides should just be communicating using HTTP 1.1. Once we've made a request to the server, we'll get back a response, and at the top of the response is the status line. The status line tells us how that request actually went. Was it a good request? Were they able to retrieve the data that we were interested in and successfully send it back to us? All of that information could be included right on this one line here. First piece of information is, yeah, I speak 1.1 HTTP, so we'll confirm that. But then the next two pieces of information, which are very useful, is the status code. How did this operation go? 200 means everything went okay. What does it mean if it didn't find the document we were looking for? What number would we use to represent that we didn't find the document we were looking for? 404, yeah. Everyone's seen that, right? 404 not found. And people create these pages that are quite nice to try and represent that, because it's something that happens commonly. If you make a GET request to a path that doesn't exist on a site, then they should send back a page that says, well, 404 not found. We don't have that thing you're looking for. So we could put 404 not found instead of 200 okay. And then, well, I don't know, we could put 400 would mean that the request was bad. 500 would mean that the server crashed maybe while it was trying to do this operation. There's lots of these different codes out there. That's not, we're not meant to remember them all today, and I will go over a few more by the end of the hour. So, first act here, we'll talk about the client. This is the device, the browser. That's your client. It's not the only client, though. We can have lots of different clients that can all speak this language. It's just that the browser is the one that you use most often. So I'm going to kind of show you what this looks like here. There's lots of different options when it comes to making HTTP requests. So I said the browser is one option. I can type in a URL. I go to my browser and I type in https github.com/jensen/http notes. The path that I'm making a request for is /Jensen/http notes. And I'm doing a GET request to the server for this path. So I just refresh this page. Oops, I'll refresh this page. And at the very top is my first request here, HTTP notes. And if I look at this, they actually give me a little preview of what this looks like. It's just, well, that's just the page, right? That's just the page I'm looking at right now. And the response is what actually came back from the server. This is a whole bunch of HTML that represents that page that I was looking at. In the headers, we can see that I did a GET request to /Jensen/HTTP notes, and it came back with a response that said 200 OK, and here's the HTML for you. Right? So this is how I'm able to now see this page in my browser. This is the host name. It's not the path. It's the address to the server, so that when I connect to the server, now I can make the GET / request or the GET /Jensen /HTTP notes request. But first, I make a connection to GitHub.com, and then I do a GET request to / Jensen HTTP notes. Does that make sense? Okay, that's the structure of the URL. Now, the browser, that's one way for me to do it. I can also do it with curl. Has anyone not used curl yet? We've all used curl a little bit. We typed it into the, what a drag, right? In the command line. It's not very nice. There's another option if you're interested in the graphical user interfaces. This one's called Postman, and it allows you to, oops, no, that's not what I wanted. Postman. I might not have it installed here. It's a GUI application. Give me a nice screenshot. Well, kind of gives you an idea. What you get to do is define the request you want to make that says GET, and then the path you want to make it to, and you can save these requests and then go back and rerun them. So it just kind of keeps a record of the requests you've made. Maybe you want to make a different type of request. You want to put some more data onto it. These things can get more complex. So you can kind of keep a record of all the requests that you've made, create collections, share them between teammates if you want. So if you have a big list of requests that you're using to test your web server, maybe you share that with a teammate so they could use the exact same list to make their tests as well, save them some time. A tool like this can be very useful. There are other ones too, HTTP-IE here, which is this. It's a little bit of a nicer way to do it with than curl. That's what they're saying. This is better than curl because it looks nicer. It has color and stuff. I'd probably agree with that. The messages are a little bit more well formatted for you. So feel free to use this if you want. The whole point is just to use we just want to use like a client, some client we can use to take a look at the messages, the communication that's happening between the two devices. So here's another one, PAW. This one you pay for, but you can see here I can I can make a request. I can choose what type of request it is, and I can so I can do github.com /Jensen /HTTP notes, and when I make that request, it's giving me a redirect because I didn't put HTTPS here. Let's try that. There we go. And then I get back all that HTML, the response as raw. I can see it all here. If I want to take a look at the raw text of a request, because with HTTP we only send strings back and forth. Everything that we send back and forth is just a string, something you'd put into double quotes, right? So to be able to see what that looks like using curl, we use curl-v to enable the verbose mode of curl, one that gives us a lot more output. And that's going to give us, first off, information about the connection that's being made. So I said the first thing that happens is it actually connects to the server using the host name. Once it's made that connection, it sends the request. And this is just a plain text message. It looks like this. The first thing is the request line, get / with the version of HTTP. Then we have a bunch of different headers here. And this is actually sort of metadata about the request. So for example, this includes information about the agent or the agent, I guess it's the piece of software that's making the request on your behalf. And in this case, I made the request with Karl. If I made the request in the browser, my agent would say Chrome or Firefox or something like that instead. Right? So the header is what we're doing is we're sending a little bit of information along with the request, something that's not part of, let's say, the body of the request, which is the third part. And here, this request has no body. We can see that the request just ends right here. And then these little arrows, these are not actually part of the request. This is just the curl program telling us that this signifies data that went to the server. Arrows going maybe, well, going that way, I guess. And this is the data that came back from the server. This is the response. So arrows going the other way. The response starts off with the response line. It says, yes, I speak HTTP 1.1, and everything was okay. 200 is the status code we use for that, and the response text, I guess, is okay. And then we get a whole bunch of headers. That's what this is here. These headers describe the information that is going to get sent back in the body. So one of the things that might be interesting is what type of content is being sent back to the agent, to the browser, to the client. And in this case, it's some HTML. So now the browser can say, oh, the content type is HTML, then I should render this as HTML rather than it's JSON. I'll render it as JSON, or it's plain text. I'll just render it as plain text. The browser can use this information. It can, the date is going to be tacked on to every single response. We're going to know when that response happened. What else here? Content length, for example. 1270 bytes, so that's the number of characters that are sent back in the response. It's telling me that this body here, this HTML that's sent back, there are 1270 characters here. Okay. And then the third thing, so we got the status line, we've got the headers, and the third part is the body. So let's go over this quickly. Yeah, get the slides back up. So these are those three parts. Super important, the method and the path. This is what we have to remember, and everything else you just look it up when you need it. Okay. So like I said, the request line is that first line, has the method, the path, and the version, or the version. And then we have the headers. So I showed those headers to you. That's the second part of the response. All of this here. The headers stop when we have a blank line. So that's how the things that understand HTTP, that's how they know that we no longer have any more headers, is because we have an empty line with a new line, and then it starts the body. So it can tell that the body starts here because of this new line. The body is the third part of the response or the request, and it just contains whatever data you want to pass back. It could be an image, could be HTML, could be JSON. It's whatever type of file is being sent back in the response. Okay. So any questions about these things here? I was able to make the request in Karl. People can see how to do that. This is a good way to debug your requests. I think I have it. Yeah. And so here's that other program that I have a link to in my notes. And it just has a little bit of a nicer syntax, or a little bit of nicer highlighting, if that's what you're interested in. Okay. So let's look at these. The method. Like I said, this is the thing you have to remember. The method is one of the things you have to remember. So let's learn the 4 most popular options for method. And we'll start off with the 2 most popular and the ones that you're going to be using this week. I'm going to talk about safety first. This is a very important topic when we're talking about web servers and these methods. So safety is this idea that when I make the request, I'm not changing the behavior of the server at all due to my request. When I do a GET request, I ask the server for data. It just sends me that data. The server will send the exact same data on the next request. It'll send the exact same data on the next request. But there are operations that change the state of the server. So let's say that I have a blog, and my blog lists out all of the blog posts on the front page. And then I make a request to add a new blog post to my blog. Well, the next person that goes to list all those blog posts will see that new post that I just added. So that's a change of state to the server. In order to add a new post to my server, I should use a post request. So in order to change the state of my server, in order to perform an unsafe operation, I'm going to call this a post request instead. So in order to retrieve data from the server, in order to not alter the behavior of that server, we're going to use a GET request. And when we want to change the state of the server in some way, add a new blog post, add a new user, anything like that, we would use a post request instead. And that's to signify that this is not a safe operation. Okay, so this is what we want to remember. Safety versus not safe, GET versus post. Retrieving data versus sending data. Okay. The other major difference is that the post request allows us, or we pass data on the body of a post request. So when I'm creating a new user, for example, I'm going to do a post request to the /register path. Does that make sense to everyone? A post request because it's going to change the state of the server. I'm going to add a new user to the database, and it's going to the /register because that's sort of the type of action I'm doing. So I pass the username and the password on the body of the request. So I've got get /register HTTP 1.1, and then I've got the headers for the document, and then in body I pass in username equals my username and password equals the password I want to use. So that's when I would use a post request, is if I want to pass data to the server and I want to change the server in some way. Yes? Question? Mm-hmm. Oh. Yeah, so the question is you kind of answered it yourself, right? Okay, so yeah, so the question is, just so Calgary is aware, when you make a GET request to a server to get data, does it send a post request back to you to send the data to you? No, it does not. This is the communication always going to be, I send a request and I get a response back, and it's going to be these two types of messages. It's going to be the GET request is going to have the information we're looking for, and the response is going to have a status as to how that request actually went, including all the data that gets sent back to them. So on the body of the response is where that data gets sent back to the user. Okay. Whereas we don't normally pass things on the body of a GET request because there's not much reason to do that. Although I think you can, although I've never done it, so I would have to, I'd have to try it out. But a lot of these rules are not enforced by anything other than us. Like, we have to enforce these rules ourselves. So learning them well enough to be able to do that. Unfortunately, the software isn't going to necessarily enforce that for us. Whether or not we change the state of the server when we do a post request or not is kind of up to what the server does when it receives that request. Not necessarily just it being a post request doesn't make that happen. But we do use these different methods to be able to kind of differentiate the types of operations we're doing. You think about this, think about old web, okay? Because this is where these things came from. It's old web, and today we kind of think about the web differently. So when I say that it changes the state of the server, it used to be where this HTTP was created was for scientists to be able to share their documents across, these large, like CERN and stuff like that wanted to share these documents. And so HTTP was what they created to share these hypertext documents, these kind of marked up documents, scientific documents. And so what they did was actually create a system that allowed you to get the contents of a file. And so when you do a GET request, what you're really doing is just saying, I want to get the contents of this file, whether or not it's an HTML document. They didn't really have images back then, but eventually you could do it with images as well. I want to get this file, so I get the contents of this file. well, I want to post this file. I want to take this file that I have on my machine, and I do not have it on this server yet, and I'm going to post it for the world to see, and other scientists can then get that document. So that when we're talking about files and actually getting files and posting files, this kind of makes sense. And so when I change it, say this, the server state is changing, I mean that if I try and do a get for a file that doesn't exist, I'll get a 404 back. When I post that file, it now exists, and when I do that request again, I don't get a 404 anymore, and that's a change of state to the server. The server didn't used to have a file to send me, and now it does. It's all that post request that changed that state. The GET request had nothing to do with it. Kind of make sense? So that when we're thinking about files, this is kind of a different story. But now we've moved this into databases, for example. Now when I do a GET request, it might do a query to a database, get some information, then send that back to me rather than sending me a file that's stored in a file system. When I do a post request, it might add a new entry into the database. But it's still the same kind of an idea, is that when that entry is not there and I do a GET request, I get a list without that entry. And when I add that thing and I do that same GET request again, now I have that. So there's a change of state. Kind of makes sense? That's what safety is all about. And then body, again, it's just the body of the request. Do we pass data or not? And with a post request, we normally do. Okay, so these, yes. Mm-hmm.
Usually, is there some validation on the system on the server side?
Okay, good question. Yeah. Yeah. Okay. Cool. So, question is, on a post request, is there typically validation on the server to confirm that the data is accurate, or or the application? Yeah. So, validation on the client side exists only for the user, because there's no security on the client side. Right? When I'm making these requests, I don't need a website with forms in it to enter my data. I can just make the request and send it in the body of the request, and it's like I typed it in a form and hit the button. So there's no security in the client side of the web, but there is security if you decide to. You can do validation on the server side and say, when you make this request, if it does not include this data on the body, then I'm going to send back a response that says that there's an error here. So some 400 code might make sense, or 403. If you try and make a request and you're not authenticated, you'd send back a 403 forbidden code, for example. So I guess, I don't know, does that kind of answer a little bit? I can keep going.
No.
Okay. So we've got these other two. We're going to be using get and post for this project this week, so you don't need to use put and delete this week, but I'm going to just tell it to you because after this week you should start using them, so it makes sense to just let you know that they exist, right? But the activities are not going to guide you to using these. I think one of the stretch activities pushes you towards that. So put and delete, if we have get and post, which is kind of like this retrieve and then create, we've also got put and delete, which are these things like replace or update, and remove or delete. I guess that's a good word for it, right? So this resource, this file that I've now uploaded and I'm able to have other people get, I could also replace that file with a new file that has updates to my document, right? And in order to do that, I wouldn't do another post, because that would actually add another version of that file on the server. That would be the intention. Instead, what I would do is I use a put request, and that is replacing an existing document. So I've got this document here. I replace the existing document with this new document. I've just done a put request. Body data makes sense for that because, like a post, I need to pass information along. It's not safe. Okay. Delete is the fourth operation that we kind of want to do to these resources. I'm going to call them resources. This file that's sitting on the server, this entry in the database, we'll call all those things resources, because you're going to be talking about resources going forward. So when I want to delete a resource, it's not a safe operation, right? Because that resource is there on the server. Someone makes a request for it, they get it. As soon as someone makes a delete request to get rid of that resource, well, it's gone, and now the server state has changed. So not a safe operation. We also don't pass body data for a delete operation. We don't really need to pass. We're deleting things. We're not adding anything or replacing anything. So body data isn't really needed for that. So keep this in mind. It'll be in the notes, and since you keep in mind this matrix of sort of these rules, safety, and whether or not we need body data or not on that request. Okay. So this is all about the method, and I said that this is one of the two key ideas we have to really get. We have to remember these things from the method. There are more methods out there, but you won't need to worry about them even for this boot camp. Not really something you'll be concerned about. So remember these four. And then the path. So I'll just tell you quickly that paths use forward slashes because the web is older than Windows. I mean, that's got my explanation for it. When I was growing up, I used Windows a lot, and so I got very familiar with this C:\/ kind of way of doing paths. But Unix, Mac OS, Linux, all that stuff, they use the older way of doing paths, which that's what I would, if I had to choose today, that's what I would go with, using forward slashes. So your paths as well on the web, since all those web servers that were used at the beginning of time, they use forward slashes, you will as well. So just keep that in mind. Don't put backslashes, use forward slashes. The only thing that really uses these backslashes is Windows anyways. Okay. And forward slash is the root path. So I could go /index.html. Usually index.something is thought of as like a default file in a directory. So if I go /, usually it's loading up index.html. Yes. Good question. Yeah. So question is that /? So not having to put a / in there, is that just convention? The browsers will just look for index.html. And it's actually not the browsers that will look for it. The browser is going to send a request get /. But the server, Apache, for example, is configured to say, well, index.html or index.php or index.whatever is the file. It's in there, so that's what I'll serve. Otherwise, I'll consider the directory not to have it's usually the server that decides that. Yeah, the client is always just going to make its request for get /, and it could say get / index.html, but then the server has no choice. That's what it should be looking for specifically, right? So it's more of a server configuration thing. So yeah, / is typically the root path. Keep that in mind. And so this HTTP request, what I want to do here, I just wanted to call out the pieces of it, parts of it again, just to really nail it down. And again, it's hard for me to go over this too many times. It's just plain text being passed over the network. There's nothing special about these messages. They're just text with new lines to distinguish between the different parts of it. Okay, so then we've got this. We've talked about the client quite a bit. We'll talk about the server, then we'll take a small break. We'll come back, we'll do the live coding. So response is what it looks like. Starts with the status line, confirms the version, gives us that status code and response text, and then maybe some headers and the body. Here are, let's say, these 5 codes. Let's start with these ones. And you don't have to remember these. You still don't have to remember these. Go onto Wikipedia. I don't know, bookmark the status code Wikipedia document. Or, I think I've got it in my notes. And anytime you come across a status code that you do not recognize, just go look it up. And over time, these common ones like this that are common will just become familiar to you. You will remember them. But it's not the kind of thing that we have to make an effort for. So here we go. 200 OK. That's going to be hopefully the most common one you see. There's also a 201 created. So normally when I create a new resource, if I do a post request and it adds a new blog post, let's say, my response actually comes back as 201 created. I prefer that. And that's actually normally what I'd want to see there. So there are more than this. I would accept 200 OK for that as well, because I think that 200 OK should work kind of in any situation that everything went good. But you can get into more detail with your response codes, and it is up to the server to decide what codes it sends back under what circumstances. Okay. And then it's up to the client to handle those things relatively nicely. So more on that tomorrow. I think I'm not sure who's teaching that, but you'll talk about web servers tomorrow morning. Do we have any questions? Yeah, question, yeah. Yeah. That's right. So the question is, put is more for replacing things, whereas post is more for creating them at the beginning. Is that what you're saying? Yeah. So let's go over quickly the HTTP put specification, because this is actually pretty interesting. Let's see. As long as I can find it. Yeah. Okay. So this is the W3 RFC protocols RFC. This is the specification for how HTTP. This is the definition of the rules for HTTP, so that people that write software that use the protocol, that their software will work. So they read these documents and then they write software to adhere to these rules. Here's the put request, and let's see. Oh, there's like a really good, just like up the other. Yeah. I'm not sure exactly if the text, I'll find it during the break, but it basically says that a put request, what it'll do is it'll replace the existing resource with, what you want to do is you want to give it an exact a representation of a new resource. So the thing that exists already, maybe with modifications, and then you're replacing that thing over top directly, completely. And if it doesn't exist, it's actually creating it. So a put request would create a resource if it didn't exist, or replace the one that does exist with a new representation of it. Yes. The idea, I mean, back when we were talking about files, I'm not sure how it would handle a situation where you tried to post the same file again. Nowadays, if I try, let's say I upload a photo to a website. When I upload that photo, the server is going to give that photo an ID, put it, and that ID is going to be in the database. And then if I upload that exact same photo again, the server doesn't know that photo is actually the same photo necessarily, but it'll just create another one with another ID, and it'll just be there. And in my list, I'd have two of the same photo with two different IDs, right? With a put, what I would be doing is actually replacing that existing photo with a new photo, whether or not it has parts of that old photo or not. That the server doesn't care. It's just taking that existing resource, replacing over top of it. So that's when I'd use a put request instead. I'm gonna I'll find this for you. Let's take a break, and I'll find that part here that I was because yeah, it's not fun to read. I think this might have been it. All right, let's get back to it. Thanks. All right, before we left, we had talked a little bit about the specifications here. And so I read this a little bit, and I kind of found the part I wanted to show you. And it was at the top. So here, this is a important sentence. And I guess it doesn't hurt for us to go through and actually read a little bit of the specification, because this is where all that information is. This is the source of all the information that I'm giving you today about HTTP is in the specification. It's just that it's not fun to read these things, so we kind of avoid it, right? But here it is. It's not that scary. The put method requests that the state of the target resource, that's why I use the term resource, be created or replace with the state defined by the representation enclosed in the request message payload. Basically, it's saying, I'm going to put the stuff in the body. I'm going to take that. I'm going to make that the resource. So if I already have something that represents this thing, I'm going to take what's in the body and replace it with it. Otherwise, I'm going to create it. And then there's another thing here. It tells us a little bit about the server, what happens when a put request is successful. So here it's saying that this is what happens when it's successful. When I make a successful put request, then on a subsequent GET request, I should get that response back as a 200 OK. So I have, let's say, file A, and I replace it with file B. My next GET request should give me file B with the 200 OK. That's what this sentence is saying here. Now, there's no guarantee of all this, because I might have other put requests happen before I do that GET request. This is HTTP. And here, this is also quite important. If the target resource does not have a current representation, and the put request creates one, then we'd actually expect a 201 created back. So that's actually a lot like a post request. So if you want to know the details of these things, this is definitely the place to get those details. It is a little bit, there's a lot of language in here that we don't necessarily need. Yes? Yeah. Yeah. A put, yeah. Yeah. Yeah, the question is, should I always expect a 201 created back when I do a post request? And I would not expect it all the time, because some people do not adhere to the standard. Some people won't. And again, like I said, it's not, the server is not going to do this for you. The server has to be written to send a 200 back when something's created with a post, or just as easily it can be a 201 can be sent back. It's really up to that person who's implementing the server and whether or not they adhere to these standards or not. Yes. So the question for Calgary, is there a tool that would help us test for this to determine whether or not our server adheres to the standards or not? And I don't know of any. It's kind of a tough problem to solve, because you can imagine, let's think of a situation. I guess, how does the tool know that that thing existed before? I guess it could probably try and figure that out and then make the request to figure out whether or not it changed the thing. So does the tool go and check to see if there's already representation for this thing, and then do a put request on it and figure out whether or not it got a 201 or a 200 back? Maybe you could do something like that, but yeah, I'd say that's probably true. So, yeah, so just that you can probably find that it doesn't follow certain rules, but not that it follows every rule. Yeah. And you're going to get 200 back a lot when you might want to, when a 204 or a 201 makes more sense or should be sent back. Here's an example. It might be a little bit advanced for today, but here's an example of a situation that I was helping a ex-student with. They were doing I think they were doing a delete, and on all of their requests, the requests were all JSON. So it wasn't HTML. They were dealing with JSON because they were just passing data back and forth between their client and this server. And so when they do a delete, I think a delete says that it should send back like a 204 no content or something like that. It'll either do, so for a delete, it'll do a 202 accepted if the action will likely succeed but hasn't been enacted yet. And it'll do a 204 if it actually has completed the delete. So there's these different options. Well, the server that the student was working with was just sending a 200 back no matter what. The delete was successful. 200 says successful. But the problem was they were actually reading the response as JSON, and it was throwing an error in their application. Has anyone, we've all seen JSON.parse, JSON.stringify? That's not news for, okay. So if you try and JSON parse something that cannot be parsed into JSON, you'll get an error. And so when it was trying to parse this empty body, getting an error, well, what you would do is check to see, is this response no content or not? Because if it's no content, then I should not parse it as JSON. There's no JSON content. So you could get into situations like that. The solution was for them to go back to the person who was responsible for writing the API and to make sure that that person sent back a 204 no content on a successful delete. That was the solution for them, right? So, but there was nothing, like they found it out as they were trying to use this thing. There was no tool. The person responsible for writing the API wasn't adhering to the standards, and this happens. So, I don't know. I guess you kind of reference back to this, and a 200 is good, but a more specific one is usually better. But I think for all yours, you won't be worried too much about the no content and the accepted and all that, and the created this week. I just want to make sure you don't think that they don't exist. I want to make sure you don't think that it's as simple as just saying, yeah, we just send 200 OK back for everything, because a good HTTP server will make good use of codes properly. Okay, yeah. All right. So I've got this example for us to go through today, and what I'm going to do is make a GET request to the nobelprize.org API. The path that I'm going to make the request to, what's the path that I'm making the request to? Yeah. Let's say specifically /v1 /prize.json. That's the path that we're making the request on. So this would be, so the HTTP request that would be created is a get /v1 prize.json HTTP 1.1. Now, when I make the connection to nobelprize.org, connection is successfully made, I send this request. Take a little bit of time, right? It takes time to get a response back. This is an asynchronous operation. So I need to use a callback for it. That's what's happening right here. I make my GET request, and I get the response back here. And then what I'm going to do is go through that response. I'm going to do a little bit of checking of the error codes. I'm going to download that response in pieces, and then I'm going to print out all of the piece prizes. So I'm going to filter out only the piece prizes, and I'm going to display those with the year and then a list of the winners. So what this looks like, that little pause, that's because it was doing an HTTP request, right? This is what it looks like from 1901 all the way up to 2018. We're getting the comma-separated list of the people that won the prize for that year. Make sense? Okay. So we all know what the goal is to write this. Now I'm going to delete that, and we're going to start it over. Okay. The only thing I'm going to keep is, well, I'll just keep this part here. I just don't want to have to go and look up that address again. All right. So here's where I'm going to start. The first thing I'm doing is I'm requiring the HTTP library. And so Node.js. Node is so based on the web that even its Hello World example is an HTTP server. It's an HTTP server that responds with any request that's made. It responds with the hello world text, right? So this is Node. Node is very HTTP, and so what we're going to do is use the HTTP library provided by Node. And this HTTP library that's provided by Node is going to allow us to, let's do it that way, make requests to a server in this case. Tomorrow we'll use the HTTP library to accept requests and send responses back, but today's only about making requests. So I'm going to head over to the documentation for this. And it's really not easy to read these Node docs, I find. Like the documentation for Node is a little bit hard to read. The section that I'm interested in right now is the HTTP section. Usually those things that we require will have their own sections here. So if I want to require the operating system module, the OS module, it would be OS or path. HTTP is what I'm into today, so I'm going to take that one. And part of this is that there's actually, it's not split into two pieces, it's all contained within one. So HTTP has the concept of a request, and then also the concept of a server. Okay. So we're only concerned about the request stuff today. Tomorrow is when we'll do the server stuff. I also have a bunch of these methods here that can be called on HTTP, including one called request, or a slightly different version of one called request. So we can actually have the same method, but two different sets of parameters passed to it. And we're seeing that the same thing is done over here with this shortcut for get. So if I want to make a request, then I would probably just do HTTP request, and I can give it a URL, and I think in that case it will probably default to a GET request. If I give it options as the first parameter, the URL that I'm going to make the request for, the path and the method, it's all going to be included in this options object. So let's actually look at what this might look like, and it's the same for get. So in this case, well, actually no, let's do it with the request first. So for request, instead of passing the URL in like this, oops, I'll just create that as a string. Actually, we're not doing that yet. That's after tomorrow afternoon. We'll do that later. So now, when I make my request, I could request for a URL, but I'm going to pass it this options object instead. And inside the options object, I believe I can pass the host. I can pass the protocol to use. I can pass the, what else? Yeah, definitely the method. So if I wanted to do a more complex request, something like a put request, or something like that, I would have to use this options object so that I can actually specify the method. But by default, if I don't specify the method, it's going to just use a GET request. Okay. And you're actually going to gain some experience using this technique during the activities. So I'm just I'm not going to bother with that. I'm going to let you do that during the activity, and I'm going to actually just use my URL here directly. Okay. So what I'm doing is grabbing the HTTP library. I'm going to call a method on the library called get, and I'm going to pass a URL. That URL includes the path that I'm making the request for, and it also defaults, well, obviously, it's a GET request. So we've defined all the things that we need in order to make this request. I want to see what it looks like when we get the response back now. So I'm going to, I gotta make sure I can see the chat. Just one moment. I just want to be able to see the chat still as well. There we go. Okay. So now, when I run this, well, first off, console.log making request, and then console.log finished or received response, something like that. So now when I run this, it says making the request, it waits for a little bit because it's now doing this connection to the server. It sends get forward slash, I forget, like B1 prizes.json. And then it gets back this incoming message, which is the data structure that's used to represent the response, the HTTP response. This is going to have a whole bunch of stuff on it that's going to be hard to read, as you can see. Like, this is just a massive object with a whole bunch of stuff on it, including things like the HTTP version that was used, maybe the headers. So we actually have access to the headers on this object. I can say response.headers, and it will give me back an object containing all of the headers. I've also got a status code and a status message that I can use. So let's just pull that out and see what the status code is for this request. So instead of the whole response, I'm going to print out the whole status code. Yes? No. The question is, does it automatically parses JSON? This is not JSON. There's no JSON today. So we're not doing any JSON today. The request that I'm making, this is a request for JSON, but this response isn't JSON. This response is plain text. Like HTTP is just a plain text message, and then the node library has taken that plain text, parsed it, and converted that into an object. And that object is what we're working with today. Now is called response. It's the no problem. Yeah. Okay. Yeah. So ultimately, the contents of our body in the response is JSON, but the response object is built up by the HTTP library with the contents of this plain text message that gets sent. So if we do curl-v, then HTTP, where is it? The HTTP library will take this message, send that as plain text. The server then understands this means I want to do a GET request to this path. It then grabs all that JSON data, maybe from a database, and it then constructs a text-based response with the first line, that's the response line, and then all of the headers, and then the body, which is just plain text, and in this case, it happens to be JSON. Now, we can take this text and convert it into an object or an array of objects using JSON parse. And we would have to do that if we want to read those things. We'll get to that in a second. For now, what we're doing, for now what we're doing is we're taking this incoming message, this thing that the HTTP library has created for us, and we're going to grab the status code from that and just see what the code is. So it's just telling us the status code is 200. And if I went in and I did something else, like got rid of the E here, it gives me a 400. I would expect a 404, but HTTP is not perfect, right? Like, no, people are not perfect when it comes to HTTP. So even though I expect a 404 not found, because I put in a path that doesn't exist, I got back a 400, which is just a general bad request response. So it still says it's not good. It's just not exactly why for me, right? So who knows what they're going to... I don't know. That's fine with me, though. The point is, I only care if the status code is not equal to 200. If the status code is not 200, then that means, in this case, I've gotten an error back, let's say. Okay? I could probably say if status code is greater than 400, and then it would capture all the 400s and the 500s and not include any 300s, which are kind of redirects and stuff like that. But just to keep things simple, I'm going to say if the status code is not 200, then what I want to do is console log error receiving response. Maybe something like response.status message. And I can put maybe some strings around that or something. Okay. So I need to make sure this error exists and run it again. Error receiving response, bad request. So I can actually grab that information out of that response object Because I don't really want to do anything with this if it comes back with an error. And so that means that I should probably also return from this function. Right? If I got back an error, I'll print out to the console saying, well, there's an error, this was not a good, something happened. And then I will not continue executing any more code after that. Because the stuff I need to do next, it all requires a good response, one full of data that I can download. So let's say when it's not 200, then we just return, and none of the stuff that I'm about to do will occur when there's an error. It should only occur when we go back to 200. Okay. So what is it that I want to do? I want to actually grab, I need to now download the body of this response. When the response comes back, it doesn't come back with the entire file. Why do we think that is? If it's an HTML document, maybe it's 2,000 bytes. That's not that bad. That could probably all fit in one network packet. Just send it all back in the response. But let's say that this is a 30 megabyte or like 24 megapixel photo that's been uploaded to Google Photos, and you're making the GET request for this photo that's 30 megabytes. That's not all going to get sent in one packet, but the response can still come back and say, yeah, we've got this data for you. And so what happens is we need to download this piece by piece. When we receive a response, and that response code is 200, then all we're really learning is that we have the ability to download this data in chunks. So I'm going to take this response, and I'm going to start off with this empty string. This is going to be the body, and as I download chunks of this, I'm going to be adding the chunks of this data to this body string here. Okay? So let's say, and this is true for all HTTP requests, whether or not it comes back in one chunk or 50 chunks, you have to kind of download it piece by piece in order. So we're going to say response.set encoding, and I need to set the encoding to UTF-8. I'm going to have to ask you to, we're not going to go into detail about UTF-8 here, but this is basically just saying that this is standard text coming. Let's say that. It's just standard text coming, being passed along. It's not, there's no Cyrillic characters or anything like that. It's just standard encoded text. And we need to, this is something that you're not going to have to really do a lot, because when we move to using other libraries to make requests, this is all going to be handled for you. So you're not going to have to think about this really as much afterwards. But just so you know, the reason why I'm doing this is as I download this data, before I download it, I want to inform the program that I expect this to be plain text. Now, I don't know how many chunks of data there are, because I don't know how, I could know how big this file is, so I could know what the content length is. But I don't know how many chunks there are. All I know is I want to download each chunk one at a time until all the chunks are done. And I can use event handling for this. So my response actually has two events that are interesting to me. One event gets fired every single time the response has new data for me to receive. And the second event fires when all of the data has been sent. So response.on data provided with a function where it passes me the chunk of data. Every single time, so when I've received this response, I can now hook into this response, and every single time it has a new piece of data for me to download, it'll call this function, passing me that data as the chunk. Okay. So what I'll do here, let's take this body, and we'll add the chunk to it. Okay. And then after we've added all that data, we want to log out the body. And this should just be all of our JSON, right? And if I run this, we don't get anything out. Program definitely takes a little bit of time, but we're not getting any data out, right? And the reason why this is because this code doesn't get run before this code. Actually, it's more this code doesn't get run before this code, because it's asynchronous, right? So we also need an asynchronous way to know that all of the data has been downloaded. And we can use the end event for that. So we finish the response. The response comes back to us. We then say, I'm interested in all of the data that is also included in this response. So I'm going to hook into this event called data. When new data is received, you'll pass that in as a chunk. I'll take that chunk and I'll add it to the end of my string. So new data comes in, add it to the string. New data comes in, add it to the string. And eventually, I have this body string, which contains all of the chunks in order. And then, when all of the chunks are done, I expect this event to get triggered, which is end. And that's how I'll know that all of the data has been put into this variable for me, okay? And I'll console log it at this point. So now, it actually prints out the data because it waits until, well, first, chunk 1, chunk 2, chunk 3, chunk 4, however many chunks there are. Once the last chunk is done, it calls the end event, which actually then knows, can actually access the proper value of the body variable. And so that's what's happening here. Okay. Now when you move away from the HTTP library and you start making requests with the request library, which is a layer that's built on top, you don't have to do this anymore. It does that for you. It takes care of downloading the chunks for you, and it just sends you back as a parameter that body object. Right? So it's only with this kind of core HTTP library that we're having to think about these chunks. Yes? Yeah. Okay, good question. So the question is, are there any differences between HTTP and HTTPS with regard to how the library gets used, right? Yeah, right, because we know that there's a security difference. So one passes data securely, one does not. With Node, the HTTPS library exists, and it has the same types of methods on. I don't expect there to be a lot of difference between these two libraries and their usage. And again, at the end of the day, request.js. By the end of the day, you'll be using the request library. And the request library doesn't force you to do this chunk downloading. What it'll do is it'll actually pass you, if there's an error, it'll pass that as the first parameter. It'll pass the response so you get access to the status code if you want. And then also, something that represents the body that was downloaded for you, it did all that chunk downloading and then just called this callback with the already downloaded body, right? So we are going to move towards that. You won't have to think about what I just did so much, but you will get some experience with this in the activities today. So you will be a little bit of practice. All right, so we don't print out the body there. We only print out the body when we receive the end event, because that means that all of the data events have been triggered already. Cool? Is that okay? I know this event handling thing is kind of an interesting, kind of weird. The callbacks, are they still pretty fresh for people? How do we feel about callbacks? I know it's complex, but it's actually fun. It's a fun language. It's a fun language to write code in. Okay, this is the body. I've successfully downloaded the body of this document. So that means I have all the JSON here. I think what I'd probably do now is create a function, because I don't want to necessarily write all of the logic for what happens next inside of this end function here. That's going to be a little bit unfortunate. So what I'll do is I'll say filter and print, and I'll pass the body in there. So I'm just going to pass this off to this other function to kind of separate these things out. Now, I guess this is the body data, so we'll just say data. And filter and print, I want to filter out maybe just the Peace Prize winners. So I could put that as a parameter as well. Maybe. I don't know. The order is up to you, right? We're still learning this stuff. So I'm just going to say that there's a filter or the category that I want to filter on, and then the data that I'm going to filter. And maybe this data here, since I already care about objects, I care about arrays, I could format this, I could parse this. I could parse this before passing it in. So what's going to happen is this string here, right, which is JSON. It's a Java. It's object notation. It's the notation that represents objects and arrays. When I parse this, it'll convert it into an actual object, and that's my outer layer. My outer layer is an object here. And if I look at this in the browser, we can see that this is an object that has one key in it called prizes, and that prizes is an array of objects, each one representing a prize. If I right-click and inspect, and I go to my network panel and I load this, I can easily see the preview here. This is actually kind of a nicer way to do it. Okay, so when I JSON parse this, what I end up with in JavaScript is an object with a key called prizes in it, and that key is an array. So let's work with that. Ooh, sorry. So the first thing I'm going to do, I know this is an object that has that key called prizes. I'm going to go into that object, I'm going to grab the prizes, and so prizes here is now my array of all of the prize objects. Yeah, of course, yeah. Mm. Yes, yeah. So the question is about sort of the structure of JSON and whether or not, so what I can actually parse into JSON, right? Because do I have to put everything into an object for it to be JSON? That's the question? Let's test some of this out, right? So var obj equals a. So here's my object, and I can console log a JSON stringify version of that. Something like that. Okay, and I'm actually going to, well, I don't have any other console logs, so this should be okay. It's not going to get in my way. All right, so this is what happens when I JSON stringify this thing, and it becomes an object. And the main difference here is it's putting quotes around my key names. You'll notice I didn't actually have to put those in here, but when it becomes JSON, these things become quoted. So that's part of it. If I take this thing here, then this is what the JSON representation is, and this is actually what's getting sent over. Oh, I guess we can't really do that, right? We gotta kind of. I'll just cheat a little bit and use these. Okay. So here, these two things can mean the same thing, as long as I can console.log JSON.parse the obj JSON. So this is the two different processes I can use. I can take an existing JSON object and I can convert it to a string, or I can take the string version of that object, convert it back to, or convert it to a JSON object. So we should get the output here. So this is actually an object. I'd be able to look up the keys on that. Now, same kind of question, but what happens if we use so that's the kind of thing we have to do, right? So can I just stringify this? We'll see. Yeah, it looks fine. So I can stringify a string, which means string could get returned. Yeah, and we'll try that one. Yeah, we'll try that one next. And that actually just gives me back the text hello, which actually looks a lot like the JSON version, right? Kind of the same thing. So if I console.log JSON.parse, the string JSON. Now, oops. Oh, nice. Okay. So this is having trouble now. So if I take this and put some quotes around it, which would make it so it doesn't like to. I can JSON stringify a string. I can convert a string into JSON, but it's not going to like that when if I were to return that same string as JSON and then try and parse it, it's not going to like that. Whereas if I take an array, I guess I can probably just do this simply. I'll just do A, B. Okay, and console.log, I'll stringify this. So this is what I get when I stringify it. If I take this same thing, of course I have to put the right quotes around it, otherwise it doesn't like it. Then that one's fine. And one thing I want everyone to remember is that at the end of the day, arrays are objects. In JavaScript, arrays are objects. Arrays are objects that have a length property, and all of their keys are indexed by the numbers, right? So when I that could be the first index. There's the second index. And you probably also want a length key property, right? And that's going to have like a 2 on it. So arrays at the end of the day are just objects in JavaScript. So yeah, they can be parsed, or my bad. I double stringified that, right? Yeah. That looks better to me. Question? Are any objects an object with a function as a value? That would be hard to stringify, right? I mean, there are ways for us to do sort of like remote function calls. You could pass all the information. You just really can't pass the implementation of that function as JSON, right? So yeah, there are objects that would have things like functions that wouldn't be stringified properly, right? Wouldn't be able to stringify like that. It would probably just to-string the function. You'd have some text, maybe, I don't even know what it would, yeah, to be honest, I don't even know what to do. We could probably try it quickly here. Let's try this out. Yeah, it's not even, don't even think it's including it. I would expect it in this one, right? Yeah, okay. Yeah. So normally if I'm returning JSON back and I want to, I'm normally going to have to return an object. Normally you'd have maybe the data on that object. It could be an object full of data already. This could be like an ID of a user. So you could send it back just, I could receive back just an object that represents some resource. I could also get back an object that has things like this, where the prize is a subarray. All of this kind of depends on the person implementing that endpoint, and also you when you're doing it, you get to decide. this data structure. I would say try and be consistent with it. That's probably the main thing. Be consistent with what you return so that it's predictable, somewhat predictable. Okay. So we'll get there. And when I left off, okay, nothing happening, good. Just a little bit of a pause, and that pause is due to this process of downloading this stuff. So I'm going to filter out the piece prizes and print each of those. How many are there? Let's find out. 590 total. Now, if I filter out based on category, I expect there to be more like 120, 119, 120, because I think it started back in the early 1900s in terms of this list. When I look at the data, it looks like, if I go all the way sort of the end, yeah, 1901. So I expect about 119 of them for each category. So what I want to do is take this array of prizes, and for each of the prizes, I want to only keep the ones where the category matches the filter I'm trying to do here. So when it matches piece, then I want to include it in my list. Otherwise, I'm going to leave it out. Cool? So have we been using the filter array function at all? Okay. So let's var r 1, 2, 3, 4 r.filter, and then what I get here. This is an interesting interface to these functions, because I have to pass it a function, and that function is going to receive back the item that it's currently looking at. And if I return back true, then the thing that I'm looking at currently is going to be included in the new array that this passes to me. Okay, so I take my original array, 1, 2, 3, 4, and I call filter on it, and it then gives me the opportunity to have this function called on each of them, passing the item. The first time it's called, I get the value 1, I return true. I get the value 2, I return true. 3, I return true. 4, I return true. When I return true from this function, it is included in the new filtered list. So both ARR, and filtered will be the same, okay? In this example, they're the same. What am I testing for now? Oh, sorry, yeah, item, yeah. Sorry? Yeah, even numbers. So this operator here is the modulo operator. If I take the number 2 and I divide it by 2, how much is my remainder? Louder, please. I kind of hear 0. 0, right? So when I do this, I'm getting 0 as a remainder, which means that this is perfectly divisible by 2. And so when I'm dividing numbers by 2 and they're perfectly divisible by 2, they're even numbers, right? So here I'm filtering only the even numbers. I only want the even numbers. When it matches this condition, include it in my filtered list. What I end up with after this is an array of 2 and 4, okay? And if I wanted to, I could filter out only the number 3. And so what this would give me is an array with just the number 3 in it. Now, you never really do this. This doesn't make a lot of sense. What if I wanted to delete the 3? It's a way for me to delete the 3 out of that list, right? So filter is quite useful. We're going to use it to filter out only the objects that have a category that matches the category we passed in here, which happens to be piece in this example. So we're going to take our prizes list, right? Filter it. For each prize, we're going to grab the prize.category. That's just from here. Prize.category. And as long as it is equal to the category that we pass in here, then we should have a filtered list with a length that matches better that 120 or so. Not 99? What did I do wrong here? Maybe piece prizes are... Let's see. That's okay, so some prizes started later than others. That seems to be what the discrepancy is there. Okay, so I'm going to stick with piece, though. All right, so now I've got these 99 prizes that I want to list out. And so I could filtered dot for each them, and each, this is again, I'm going to be passed the prize here. Console log the prize dot year maybe. See what that looks like. Okay. Now I've got the first part, which is the year. And then what I want to put here is a list of the winners for this prize. And I could, if I look at the data structure, we see that that's actually stored within this array here called laureates. I can never remember to spell that. I'm just going to copy that now just for later. So this is the laureates, and each prize might have 1, 2, 3, could have a number of different items in this laureates array. So what I need to do is actually iterate through the laureates array, take each first name and surname, put them together, and then separate them all by commas. Does that sound like a good plan? Okay. So let's create another function here. Get winners, and I'll just pass it the prize object. Okay. Now this function is going to know how to take a prize object, which is just one of these things. It's going to take this one prize object, oops, and it's going to go and it's going to grab this, and it's going to return a comma-separated list of the winners. Okay. We'll say var output is equal to empty string maybe. And then I need to go through prize.laureates.for each. And this is going to be a winner that I get back here. All right, so I go through each of the laureates, each of the winners. And for each of the winners, I'm going to output plus equals the winner.first name. And I'll put a space in there and then give us the winner.surname. And then I'll just return output. All right. So now, if I call get winners with the prize here, okay, good. Then I should be able to, okay, almost there. I did make one mistake, that I didn't put that comma in there, so I should probably do that. It would be at the end here, right? So that's, oops. Better? There's one slight issue. It's got this trailing comma on all of these, right? So if I want to fix that, I could do that in here, right? How do I do this? What sort of logic would I need in order to fix this issue of the trailing comma? Condition, okay. And what's the condition? Cool. Cool, got it, yeah. Perfect. So I'll grab the index, yeah. Great. So if the index minus 1 is equal to the length, or I'd say if it's not, right? Or if it's, or if it's, less than, maybe something like that. Does that work? And then what I'll do is I will add to the output You're right. Oh. Oh, hold on. Output plus equals index. Right. Yeah. So yeah. You know what? This is kind of a pain, right? Like, why would we want to do this? Why would I write this logic myself? I'll take this prize.laureates. I always forget how to do this. Laureates. Okay, I'll take this prize. Oh, come on. I'll take prize.laureates. And what I'm going to do is, for each of the items, I actually just want the first and the last name. I'm going to create a new array of first and last names, and then I'm going to join those together and return that. Because then I just let the working code do the work for me and not have to deal with this off by 1. Is it -1? Do I have to do less than or equal then? Or why would I give myself that type of level of stress? So what I'll do here is I'll map instead. And the map is going to take, it's still going to iterate over every single laureate, but it's going to allow me to convert a list of objects with all of this, or with all of this data in it, into a list of first and last names with a space between them. So let's look, we'll look at the in-between in a second here. Let's say, yeah, okay, we'll start with this. So here's a winner. What I return from this function is what I want to replace this index. I'm going to create a new array. Right now I have a list of laureate winners. I'm going to take the first name and surname, and I'm going to make that now the item in the list. So here, I'll show it to you. It's probably better that way. Okay. So I'll take this result and I'll log it out. So now these are all the things that I'm creating. When I do that map, this thing at this index used to be an object that had all of the information about the laureate, including their ID, the first name and the last name. What else is on here? We got the ID, the first name, the last name, the share, and the motivation. All of that data was there, but we didn't care so much about that data. So what we did instead was we converted this from a list of these objects into an array of strings that have the first name and the surname. And so here is the first name and surname for that first object, the second object, and that looks like actually two people combined. I don't know. I don't know how this works, but yeah. So I can return this, and if I have a if I have an array of names, then I can join them on the comma with the space between them. So now all that logic about is it the last item or not is passed on. That responsibility is passed on to this other function. And so now when we print this out, we get nicely printed names, no trailing commas, and we've used the map function to convert our array for us. And that's part of the reason I went through that kind of hassle, right? Is to show you that these functions exist. Map and filter, very useful. If you ever see yourself doing something like this, where I have this output, and then I'm trying to, actually no, this one's a little bit different. This one's more of a reduce that I'm doing here. I'm taking an array of names and I'm reducing it down to one string value. So, but I'm kind of doing it in a quite a verbose way by creating that variable myself. So there's alternatives to these. I've got some notes for those in my documents here. So right at the end, it talks a little bit about using filter and using map. And around now's the time to start thinking about these things. You don't have to, if the alternative is more clear for you, feel free to use it. Feel free to submit your assignments with that. But as you gain more comfort, start to use filter, start to use map, because these are going to make your lives as JavaScript developers much easier. No questions from Calgary as I can see. I figure I'm not going to assume I told you everything you needed to know, so I figure you just don't have a lot of questions. But if you do have questions, feel free to message me on Slack. It's just Jensen. Same is true for all of you. I will be back at 3 o'clock, I guess 4 o'clock as well for the next lecture, which is about Node apps. And I posted the notes in the Slack channel for you to see those ahead of time if you want, if you're a bit ahead. Thanks, everyone. Yeah.